We have been dealing with various topics in this course. I don't know if you remember, recollect what we studied first. Is there any class you can say what is the first fundamentals of machining? So where we studied the basic principles of metal cutting. So metal cutting is actually metal removal process. So somebody said that when additive manufacturing came, so earlier manufacturing was negative, so now it became like plus positive. So that's what they say. So manufacturing means it is removing the material and making the shape. But nowadays we have the process which are called as additive manufacturing processes. So where we build the wall or the structure where it is required. So probably toward the end of this course, we'll talk about some of the advanced manufacturing processes. So in that we'll include even additive manufacturing, so that you are aware of latest machining processes what are going on in the industry in the present day. So the fundamentals of machining means it is like metal removal. So metal removal processes. So even the title of your course, it says metal cutting and machine tools. So additive manufacturing, 3D printing, and all these layered manufacturing kind of process are not included in this. So probably we can ask your professors to revise some of these syllabus maybe in the coming semesters, so that you will be aware of the latest developments in the manufacturing area and also in the industry. Then in the second unit, we were talking about the machine tools which are being used for making this shape. So the primary aim of manufacturing is we need to make the components to the required shape, size, and finish. So that is the basic aim of it. So various machine tools we have seen, and somebody said the mother of all machines is a lathe machine. So that is what was the first machine which was invented. So thus lathe machine, if you understand the basic working principles of it, so other machines you can understand it easily. So we have looked at the basic machine tool structure, various functions, and other topics related to the lathe machine. Next, we have looked at the shaping machine, the slotting machine, and planing machine. So where lathe, shaping, slotting, and planing machines are will be using the single point cutting tool. So though literally it may not be a single point, but only a like it is not an edge, but a point or a small portion of the tool will be making the contact with the workpiece. So all these things come under what is called as the single point cutting tools, and the lathe, shaping, slotting, and planing machines will be using the single point cutting tool. So then later we talked about the milling process and then the milling machines. So milling machines are multi-point, milling machines use multi-point cutting tools, and then they remove the material. So we have looked at various milling processes. So the basic processes like face milling, end milling. Then we have looked at the type like up milling, down milling, and also various cutters, their geometry, and also their methods of indexing, and different types of milling machines, their structure, and their main components. So then later we moved on to the finishing processes. So where once you do the basic machining operations, so as I already said, so the manufacturing, overall manufacturing operations can be put as primary, tertiary, and secondary operations, or primary, secondary, and finishing operations. So where primary operation generally includes the metal forming, casting, and forging kind of processes, which will give the basic shape to the component. So then we do the machining so that we bring them to the exact size, form, and finish. So that is size, then shape, and also to the required surface finish. So then under this, the tertiary processing or the finishing processes, so where highly finished surfaces with high requirements of tolerances and surface finish. We can achieve them by using this type of finishing processes. And the basic finishing process is grinding. So where we have looked at the grinding process, though the abrasives have a single point cutting edge which basically makes contact with the workpiece while removing the material, there will be several such abrasive particles. The sharp edges of the abrasive particles will be making contact with the workpiece simultaneously at a time. So that is the reason even the grinding process is also comes under multi-point cutting operation. So then we have looked at different types: cylindrical grinding, surface grinding, and then tool and cutter grinding, and different types. Then later we have looked at the super finishing operations. So where if the requirement of surface finish and also the form and dimensional accuracy are higher, we go for this kind of a processes. So lapping, honing, broaching, and then buffing and other types of processes. So one of the most popular one is the honing. So if you don't have this honing process, I think many of our engines, IC engines and other engines will not be working. So every time you make the cylinder or the cylinder liner, so they go for this honing process. So it is one of the like a necessity or requirement of the surface finish. So I think I have explained to you in the last class. So the pattern what we need inside the cylinder liner. So there will be two types generally, either they insert a cylinder liner or in the engine block itself they machine. So that is the reason I'll be alternatively using these two terms. So either it is a cylinder or the cylinder liner. So cylinder means it will be a cast part. So inside that you are going to machine it. If it is a liner, there will be a cast part. Then a cylindrical liner will be made separately and then inserted into the cylindrical hole which will be there in the casting. And earlier these engine blocks are made with cast iron. So they cast the iron and then they make that cast iron. But now because of the weight constraints, even in our automotive, generally cars and even other things, so they have shifted to aluminum alloys. So we use the aluminum alloys for making those cylinder casting. So then inside the cylinder bore, you cannot have aluminum. If aluminum is there, it can't withstand the high temperatures there. So if it is, the casting is aluminum, then the liners are a must. So you have to insert the liners, which will be basically of cast iron. But if the cylinder block itself is cast iron, either you can have liners or we can machine the bore itself, and then we can use that bore as the engine, put the piston and valves and other assemblies we can make. So thus in the honing process, we need a cross hatch pattern to retain the oil, and at the same time we need to have a very good surface finish. So the surface finish will be sub-micrometers like 0.1 micrometer RA, average roughness. So this is a kind of a range of surface finish what we are looking for. So even in this, nowadays they have different types of honing processes. And so where, so if you have a honing surface like this, so these peaks are not necessary, actually we don't deserve them, so they need to be removed. So there is a honing process, the name of it is 1 minute, I'll recollect that name. So where the tops of it will be removed and only the lower part of it, the valleys part of it will be retained, so that oil will be retained inside this kind of a valleys. And earlier, if you have heard about the engines and all, when you buy a scooter or a car, so they say, so until first 1,000 kilometers or first 6 months, so don't go beyond 30 kilometers or 40 kilometers like that. Why that? Because when they didn't have the process, when there were valleys and also the peaks like this kind of a surface finish, If you go very high speed, so these parts will break and then the cracks may be formed and even the engine can get seized. But nowadays we have that process. Just give me a minute. I'll recollect what is the name of that honing process is called. Mm, where it removes the top part of it. I'm not able to recollect that name right now. Okay, so I'll tell you the name when I get it. So the top parts of it will be removed, and because of that, nowadays when you buy the new automobiles, say the two-wheelers or four-wheelers, so there is no speed restriction for the initial years. So they say, okay, at whatever the speed you want, you can drive right from the beginning. That is because the top parts of this portion will be machined. So otherwise earlier, so they get rubbed and then they get worn out during when the engine is running. So that is one of the advances in the honing process. So this is what about the finishing processes. So what we discussed in the last class. So now this part, this is the 6th unit in your syllabus. So where we'll be talking about the jigs and fixtures. So we'll be talking about the jigs and fixtures, and also the second part of it, it talks about the CNC machine tools and various details about the CNC machine tools. So what I'm planning to do is, after these things, so we'll be talking about some of the advanced manufacturing processes like micro machining, high speed machining, and then additive manufacturing. So for you, I think always I put this slide about the textbooks. Why? Because these days people have forgotten the skill of reading the books. So if I give a PPT, they'll read the PPT and come for exam. So I don't recommend that. So it's always good that you read textbook, and rather textbooks more than one book always gives you a better insight into the processes. So later if you are going for higher studies, or if you are writing your GATE exam, or later if you do PhD and all, so the understanding of the fundamentals play a very important role. So whole of your career is built on how you understand these basics in any subject. So it is always good to read the textbooks. So these are the two textbooks which have been specified by the syllabus, but actually for jigs and fixtures, you can refer to the textbook Tool Design by Donaldson. So it is a tool design by Donaldson. Okay, the latest version is 4th. I think I'll show you the picture of it later. So I was one of the person who corrected these things, and then you can find my name in that 4th version. So it is tool design. Tool design means it is not the metal cutting tool design what you see. It is not the cutting tools, but here tools means the jigs, fixtures, and then the press tools. So that is the reason they are also called as the tool design. So the name of the textbook is Tool Design by Cyril Donaldson, George Lee Kane, and other people are there, but generally it is referred by Donaldson's name, who is the primary author. So Tool Design by Donaldson, Cyril Donaldson. So you can refer to that book if for this particular unit if you need more information. I think I just remind you about the class schedule. So we have this month and then the first week of October to complete our syllabus and then to look into the various details. So keep a tab of all these things. So now coming to, it's printed twice. Okay, coming to the jigs and fixtures. So if you go to the shop floor, so you hear this term, maybe in your workshops, what is there in your colleges, you may not hear them. So jigs and fixtures are more a production kind of a devices. So if you go to any industry without the jigs and fixtures, you can't work. So you need jigs and fixtures. So we'll see what is this jigs and fixtures. So as I said, successful running of a mass production depends on the interchangeability to facilitate easy assembly and reduction of the unit cost. So if you go to industry, you know what they'll be talking about? They'll be talking about the production and then the cost. So the technology actually assists them in achieving these two. Yesterday, actually, we had visitors from one of the automobile manufacturing industry. So they were talking about how the production is important. So he was talking about the gearbox which is being used in an automobile. So in that gearbox, there will be several 47 or several number of gears. So in that, in case if somebody doesn't manufacture one gear, or if instead of 47 gears, if they manufacture only 46, the cost of the gear may be like around 500 or maybe 1000 rupees maximum. But you know what is the loss the whole industry actually faces if one gear is not there? So he said that, so you can't assemble a gearbox. So without one gear, you cannot assemble a gearbox. So if there is no gearbox, so you can't assemble the vehicle. So if it is a large truck, something like which is costing about 50 lakhs or even higher cost than that, or if it is an automobile or our car or something like that, it's around 10 lakhs. So if you don't make one gear, so one car is less or one truck is less. That means you are incurring lakhs of rupees as loss. So he was telling that the production rate is very, very important. You can't compromise on the numbers. And at the same time, the quality is also important. So you want to make a gear and then in a hurry, you make something. And then if you fit it inside, so during its lifetime, when it fails, so if it is an automobile or even more risky kind of a vehicles like helicopter, or maybe even if you take aircrafts and all, so even a small failure can cause a fatal damage and life damage to the property and life. So thus we cannot compromise even on the quality. And at the same time, the numbers are also important because a company want to make the profits. And if every day you make one less gear, one vehicle is gone, means you can't offset the cost. So both are important. So how do you achieve this, or how do you make the both the ends for the production and also quality to be met? Then the jigs and fixtures will be helping us. I'm here to define you what is the jigs and fixtures. And the other aspects in production is the quality on one side, the cost is on other side, and also the technology plays a very, very important role. Yesterday, the person who visited, he was telling India still doesn't have many of the technologies like auto gear. So we don't have a technology to make it. We may be making auto gear kind of an assemblies in India, but it is not our own technology. It is like the technology of maybe Germans or other country. So thus we encourage our youngsters. So students like you, if you become entrepreneurs or the technocrats, so please look into these kind of an aspects. So where India is yet to go forward. So we have made a good progress, but still we need to go to the higher levels in manufacturing. So if you become entrepreneurs, so please see that you will do some of these things which you are not able to make in India. I think our government has been taking so many initiatives to do something like Make in India and other things. So you can join in that efforts and take the technology to the higher level. Okay, so instead of giving more of this introduction, let me go and define what these jigs and fixtures are. So you can see in the figure, so probably if you look at this figure, You can understand. Just a minute, there was someone. Okay. So when you look at this figure, probably you can understand what these jigs and fixtures are. So probably fixture may be a term what you'd heard. So fixture is nothing but a work holding device. And work holding device, not like what the wires and other things, not the standard work holding devices, apart from the standard shapes. So for example, if you have a prismatic part like a square or a cube, we can easily hold it by using the standard work holding devices. So some of them already we have introduced while talking about the lathe or the drilling machine or the milling machine. So now fixtures means they're not the standard work holding devices, but see now, for example, there is a L shape. So what is the kind of vise with which you can hold it firmly? So we need to hold them ruggedly, because when the cutting forces are there, when the machining operation is happening, and when the tool or sometimes like in a lathe workpiece is rotating at a very high speed, so there are chances that they come out. So once even here some kind of a thing happened where when we started rotating the tool at a very high speed, one of the tool insert came out. So thank God it didn't come out through the opening, but it went and hit somewhere. So there'll be something like have a velocity like a bullet. So it will be very risky. Nowadays in industry, safety is given the priority. See, for example, if work doesn't happen, also it is fine, but safety cannot be compromised. So thus you need to have a fixture which should be able to rigidly hold that, even in spite of it not having a regular shape. See, if it is a square block, if it is a rectangular block, we can rigidly hold it by using the work holding, standard work holding devices. But any irregular shapes like this, you cannot hold them. So you need something to hold it firmly, that is called as a fixture. And then in a simple terms, jig is a device that helps in guiding the tool. So here what you are seeing is a pure fixture. I'll show you the jig, then you'll probably understand it. We'll be coming back and defining them and tell what is the differences. So here you can see on the top right side, so there are these holes. So what you see, these holes, these are nothing but, this plate is a jig, and then these holes are to guide the tool. So to guide the tool, thus fixtures are work holding devices, and then jigs are the one which are used for guiding the tools. See, earlier and even now, if you go to a shop floor, you see 70% of the machines are like a manual kind of a machines, conventional machines. So maybe the other advanced machines, they'll be CNC machines. If CNC machines are there, you don't need the jig. So obviously you still need the fixtures to hold the workpiece, but you don't need the jig to guide the tool, because you can program it with the XYZ coordinates. So in the second part of this unit, actually we'll be looking at how to program the CNC machines so that the tool can go to the required place and then carry out the machining. But when we don't have that kind of an CNC, that is computer numerical control machines, so where if it is automated or semi-automated, so where you need the manual operator to guide the tool and then do the machining operation, so we need these jigs. So what is the thing, we'll go forward. So importance of jigs and fixtures. So for large scale production by semi-skilled operators, so we need these jigs and fixtures. So to define the relationship and alignment between the cutter or the tool, so we need the jigs and fixtures. And then to maintain the precision and accuracy, so we need these kind of jigs and fixtures. So for example, I think you would have worked in your workshop. If I have a 5mm workpiece like this, and then if you want to drill maybe 4 holes like this, and then a center hole, how do you generally do this operation? How do you do this operation? So think that they are given a PCD, so pitch circle diameter of maybe 70 millimeters. So you need to exactly do it, and then this angle should be 90 degrees each. So how do you do that? So the general practice in any shop will be, if it is only a single plate, so we take them to the height gauge, so it will be kept on a surface plate. Then we are going to draw the cross lines like this to locate the center, and then we take the divider, and then we take the particular radius, draw a circle there, or take a punch and mark that center. Then from there we draw a circle of 70 millimeters. Then we take the tri-square and then mark 90 degrees, and wherever that circle is meeting this 90-degree line, so we put a punch telling that that's where we need the holes. So now after marking, so your workpiece will look something like this. There will be a punch here, and then there will be another hole here, some hole. So you'll have a cross mark and all these things. Then we take this workpiece to a drilling machine, fix it. So now if it is not a special shape, so we'll fix it by using the standard work holding device. Then bring the drill bit here. So center, we'll try to mark that. Then if it is exactly coinciding with that, then you start drilling the operation. Then later we take the drill here, then make sure that the drill is touching at this point where you mark, and then you do that. Think that you need to do this kind of a work pieces 500 in a day. So you can't keep marking them and then looking at every point mark and then placing the drill and then doing it. It's waste of time, and production rate, as already I have said, it is very important. So you can't waste time like that. So in that kind of a cases, so our jigs and fixtures will come into picture. Now if you want a jig and a fixture for this, so now this example what I have given is a regular shape. So think that there is some kind of a curvature here, and then there is also curvature here, otherwise you would probably hold the opposite side. So think that there is some curvature here, not a prismatic kind of a part. So then what we do is, I'll make a work holding device, something like this, so that it can hold, and then other side it can be a flat one. And when I fix this workpiece here, so I'll have a plate, so that is a jig with the holes in the places wherever the holes are required, and generally a bush will be kept inside that. There will be a bush. So that plate I'll take, I'll fix it. So this top will be something like similar to this one. I'll fix it here. So then I can see the holes with the bushes. So wherever I need the holes like this, then what I do is, I don't need any marking on the workpiece. So I'll put the workpiece on the top of it. I'll put the jig, and then with the fixture which I have designed, so I will tighten it, then bring the drill bit and then make it to pass through this hole, that is a bush, and then automatically it will make the drilling. So thus I'll repeat this operation in all these 4 cases. So then I'll release the fixture. So I'll take out my jig from the top, then I'll take the workpiece. So it will have exactly the center hole, and then the 4 PCD holes, pitch circle holes on the pitch circle diameter where I require. So next, again I'll put the next workpiece, put this jig on that. So tighten my fixture, so do the operation. So thus I can save a lot of time, and I can increase my rate of production, and I can do these jobs very quickly. So my productivity will be much higher. So what was the sound I heard? Okay. 1 minute. Okay, that's what was making sound. Okay, is it clear now? What is a jig and a fixture and their importance? So usually in your exams or the question paper, the question will be there, what is a jig and what is a fixture and what are the differences between them? So later I'll be telling you another fact. So maybe I can tell right now. Though we have like jigs and fixtures are two terms and we call them separately, but literally in the industry when you go, so you find that both jig and fixture most of the time, so it is not a rule, but most of the time you'll find them as an integral part. Why? Because you need to hold the workpiece and you need to machine that workpiece. So thus there'll be a jig and a fixture, so which will be into which or on which a workpiece will be put, it will be clamped, and then the machining operation will be done. So many times both are integral parts. But if somebody need ask what is a jig and what is a fixture, so you need to tell these differences. So jig is a work holding device that holds, supports and locates the workpiece and guides the cutting tool. So that is the reason. So this definition they have put, but to be more specific, I can strike off all these things and then say jig guides the tool for a specific operation if it is only a jig. But many times the jig and fixtures are interchangeably used. So that is the reason they say it is holds and guides. That is what is the general definition. But if you want what is a jig, it guides the cutting tool. So jigs are generally fitted with a hardened steel bushes. So you can see here, because when you insert the drill bit every time through that hole, if the bush is not there, then your jig itself will get worn out. So then the whole jig you have to change. So that will be again a lot of cost will be involved, time will be lost. So instead of that, what they do is they'll put a bush, so where the drill bit can actually go through that. So that will be the size equal to or slightly larger than the diameter of the drill bit. So it will go inside, and then after some time the bush will get worn out. So then the errors will start coming. So you can't locate it exactly. In that case, what they do is they'll remove these bushes and place a new bush. So thus you don't have to change the whole jig and fixture, but only the bush. So that is the reason you find that they'll be fitted with the bushes. So remember that jig is a device that guides the tool. So one of these example of a jig you can see here. So these are the white ones. What you see here are the steel bushes. So this is the jig. The blue color what you are seeing here is the jig, and this white one what you see here are the bushes. So the drill bit actually will be going through that. So this is the example of a pure jig. Then what is a fixture? So fixture is a work holding device that supports, locates the workpiece for a specific operation. So then you can also say, but it does not guide the cutting tool. So if it is a pure fixture alone, so it only holds the workpiece. And then location, that is important. So we later look at what are the principles for locating the workpiece. So that is also important. Otherwise, if you don't locate it properly, so whatever accurately you machine it, for example, even in CNC also it will be happening, like you keep the workpiece somewhere instead of keeping it like this, and then you accurately drill the holes, then your center hole will be here. So these PCD holes, for the example what I said, it will be here. But actually what you wanted is at the center of the plate, but that doesn't happen. So to make it to happen rightly as what you need, so you have to place them appropriately. So you can't just place anywhere on the table and start the machining operation. So sometimes when new operators are there on a CNC machine, so they used to do like this. They fix somewhere and then start the program. They find that half of the machining will be happening on the machine and the other half outside it, or sometimes even the work holding devices get affected. So thus we need to locate them. That is another tricky job. So we have some slides on that, which will be looking at them a bit later. So a fixture is the one which helps us in rigidly holding the device on the machine tool. And also it locates the workpiece in the right position. So when you look at some of the examples, so probably you can understand about these location principles. So as of now, remember that it holds, supports the workpiece. So this is one of the example of a fixture. So this is a connecting rod, and then you can see, so these are the fixtures. So they are not like a standard shape. If it would have been a rectangular plate or something, so then you could have used a standard work holding device. But for this, you can't use a standard work holding device. If you hold them, they will escape and then they'll fly away. So thus, we need to hold them. So these things are the fixtures. But also you see here these pins. I'll explain about those. Those pins are the locators. So thus, to put it in the right position and then fixing it is, both are important. So we'll talk about this locating pins a bit later. But as of now, remember that this is the fixture which is used for holding the workpiece. So now the differences between jig and a fixture. So you can see here, so this part of it which holds, which guides the tool, that is the jig, and then the one which used for fixing the workpiece is the fixture. But usually, so the whole jigs and fixtures will be looking like this, what you see on the figure on the left side. So where there will be a fixture and then there will be a jig, which will be an integral part. So you can actually insert a workpiece, fix it, and then drill it, and then unwind this one, and then remove the workpiece, put the next one. So you can keep going on. So that's the differences between jigs and fixtures listed here. So probably you can just look at them for a minute and you can read the differences between the jigs and fixtures. So these are important from the point of examination point of view. So another way to find out what is the difference will be, jigs will be lighter because they don't need to resist the cutting force. So the advantages of jigs and fixtures, as already we have been telling, so jigs and fixtures increase the productivity by eliminating the individual marking, positioning and frequent checking. The operation time is also reduced due to increase in speed, feed and depth of cut because of high clamping rigidity. So when the workpiece is held, you can use the higher cutting forces. So thus you can increase the speed, feed and depth of cut. Then skill reduction. So even an unskilled operator, when you have the jigs and fixtures, he can do the job and consistently. So sometimes what will happen is, worker when he's in the morning, when he is fresh, he'll do the job with a high quality, but by evening when he's tired, the quality will not be the same. But now with the help of this, even though the operator may be tired or anything, but still the workpieces what you produce will be of the same quality. Then interchangeability. So we can actually change the parts. So all of them are made similar. So thus you can remove one part and put another part which has been manufactured a bit later. So all will be similar, but not exactly the same. So always remember, in manufacturing, you can never make two exactly same parts. They may be identical, they may be similar, but they won't be exactly the same. So you make the measurements in terms of micrometers, with an accuracy of micrometers. Always you find that even though they have been made in the same setup on the same machine, but still they will be different. So no two parts are exactly same. Cost reduction, and obviously you can reduce the waste, because if you put the holes example I gave wrongly, then you may have to they don't get assembled properly, then you may have to throw them, scrap them, and the cost will be lost. But now production rate will be high, at the same time the wastage will be less. So the next one is about the elements of jigs and fixtures. I think before we go into this, if you look at the video, probably you can understand
and as fast as possible. And for economy, standard catalog items must be used where possible. A machined part has certain planes, lines, and/or holes from which other points are measured. These reference points or planes are called datums. To correctly machine a part, it must be held in a setup that guarantees a definite location or position and orientation in space with respect to the part's datum points or surfaces. This must be repeatable part after part. Secondly, the work-holding device must hold the part securely in position while cutting forces, vibrations, centrifugal force, and gravity act to dislodge it. In theory, the location and clamping of workpieces are considered separate issues, but in work-holding practice, locating and clamping are integrated as part of the same process. The holding action ensures the workpiece is stable for machining once located. If not restrained adequately, the workpiece will move and become scrap. Conversely, the clamping force must not be inappropriately excessive, so as to distort, gouge, or break the workpiece. The 3-2-1 locational method is suited for rectangular parts located by their outer edges. With this method, 6 points of contact, or locators, on the faces of an object cancel 9 of the 12 degrees of freedom. These 6 contact points include 3 primary locators, 2 secondary locators, and a single tertiary locator. For accuracy and productivity, as many operations as possible should be completed in a single clamping. Reclamping or rechucking have 2 negative impacts. First, when the workpiece is moved, the location of the workpiece in relation to the machine tool is lost. That compromises the accuracy of the part. Secondly, setup time doesn't add value to the workpiece, and machining time is wasted at each unclamp-clamp cycle. Although a single clamping is ideal, 2 or more clampings or chuckings may be required when datum surfaces must be machined first, or a through hole has steps on both sides, or a part has blind
indexing device, sometimes when it's a power devices for operating the clamping elements. So when these things, the workpieces, what you need to hold them are very heavy, so you can't just clamp them with the hand. So then there'll be an assistance of pneumatic, and if it is even much higher cutting forces, higher forces are required for clamping, then we go for hydraulic also. So generally there'll be a pneumatic line, so where you press a button, so the pressurized air will come and then the clamping takes place, and then you can just release them by pressing a button, you remove the workpiece. So thus these kind of arrangements are also required if the jigs and fixtures are very large. So sometimes indexing devices are also required, but many cases, so the instead of indexing, you can change the position of the tool, but in some cases, if that is not possible, you may have to index. So indexing means like there'll be a device with a mark along this one. So if you want to turn it to a next position, so with a specific angle, you can do that. So as we have seen in the milling machine, so there can be indexing holes like this. So there'll be a handle with a pin which will be sitting in this hole. So pull it out, move it to the next hole and fix it, so you can index. So even that kind of a devices can be there in this. So they're all called as the auxiliary elements. So these are the various elements which will be there in the jigs and fixtures. Then what are the principles of jigs and fixtures? I think some terms you'd have heard in the video. So what is called as a datum, and then datum plane and all. So what is important in manufacturing is that whenever you fix a workpiece, when you hold them, so you should be able to finish all the operations within one setup. If that you can do, that will be the best. Generally the bottom surface will be machined and then made as a datum surface. So datum is nothing but reference. So why that reference is very, very important in manufacturing and also in measurement? It's because if there are any errors in the datum, all the machining, whatever you do, you'll be going wrong. And measurements, what you do, will not be reliable. For example, think that I have fixed this workpiece on a milling machine, and then I want to do the facing operation. So mill this top surface. So if I don't keep it horizontally, if my workpiece is loaded something like inclined like this, so then when I machine the top surface, so finally my bottom surface and top will not be parallel to each other. But usually in our requirement will be like this. So where we want the top and the bottom surface to be parallel. So thus it's not because of a wrong machine or wrong machining operation. Everything is good, but because you are not fixed it properly, because the reference is not good, so you can't get the accurate part. So to avoid that, so what they do is generally the reference surface will be machined. So that is in one setup. Then they'll bring that and place it on the machine, and remaining all operations will be done with reference to this one. Like for example, even the hole, if you want to drill it here, so usually designers specify it with reference to the datum surface. So from the bottom surface, if I give a height 20 millimeters, so it will be done. So thus the reference is important. So in the jigs and fixtures, that reference will be taken care. And then the other aspects, so it will be simple and easy for operation. So it should not be too complicated that unskilled operator will not be able to open it or close it. It should not be like that. It should be easy. Then rigidity and lightness, which are actually contradictory. You want it to be rigid, but at the same time you want it to be less weight. Contradicting requirement, but we need to have an optimal way of doing that. Then the fixtures also should be capable of absorbing the vibrations, so they should have a good damping characteristics. So otherwise the vibrations which are produced by the tool during machining should not get transmitted, they should be absorbed by this. So that is the reason usually when you look at the fixture, they will be big in volume, larger in size. Even though the component may be smaller, but the fixtures will be quite large and bulky. Then jig body and its fixing with machine table should be taken proper care, and it should be strong enough. The other characteristics, loading and unloading, it should be easy for anybody to put the workpiece, then do the operation, then you should be able to remove it quickly and easily. Then supporting, locating and clamping. So these terms, locating is always coming, so it is important. So the resting button, the jack pins or the V blocks, whatever we use, so they should be of appropriate shape and size. Then clearances, there should be enough clearance between the body of the jig and the workpiece so that the variations in size of the workpiece can be accommodated. And also there should be a place for the chips. So in case you make your jig and a fixture very kind of a closed one, so when you machine it, where should the chips go? So usually if you look at the design of the jigs and fixtures, so there'll be a gap which will be left, like for example, even in a design, so there'll be something like this kind of a gap will be put, so where there'll be possible that the chips can come here and then later they can be disposed. So there should be a place for the swab, chips, and then the other things, material to be removed. Then tool setting and guiding. So designing of the fixture should be in such a way that the minimum time is consumed in setting up the job, and then also for guiding the workpiece. Then ejection. So workpiece should be ejected mechanically from the jig or a fixture when it is unclamped. That is always desirable. So usually what they do is they'll have some type of springs which will be inside. So where once you clamp them, they'll be forced and will be in place. So when you release the clamp, so they push the workpiece up, and then automatically the workpiece come out of the jig, and then you can remove it more easily. If it is inside, like it is a box kind of a structure, if it is inside, it may take time. So now what they do is, it will be just like this, it will come out and then it can be easily removed. Other one will be placed and then you press down the clamp, so it gets unseated. So that is a kind of arrangement what will be done. So there should be a place to ejection. Then another important thing is foolproofing. So where there should not be a chance for the workpiece to be loaded in a wrong way or the machining to be done in a wrong way. So even if you look at our electrical plugs, so there'll be generally like 3 kind of a pins. It is not 2. So in some cases it may be 2, but generally it will be 3. And also if you look at your charger in your cell phone, so one side it will be wider like this, the other one will be smaller. And also probably if you have looked at your computers and the pins for the projector or other things, so either there will be an edge like this or it will be a shape, will be asymmetry. So the pins will be there, so which will go into the assembly, and then there may be an edge like this or smaller on this side and larger on the other side. So there is no chance that you can keep it in the wrong way. If you keep it in the wrong way, assembly itself will not take place. So thus it is a built-in safety so that you don't connect in the wrong way and spoil your devices. So in a similar way, even in the jigs and fixtures, so if you place it wrong, so probably the clamping will not happen and you can't close it. So thus the operator will come and check, oh, there is something wrong. And then he'll set the position right and then clamp it. Then safety. As I said, safety is first these days. So many of the industries are actually closed if they don't properly maintain this safety requirement. So safety is always first. You go to any industry, you see the board telling that safety is first. So later they talk about production and all those things. Then accuracy. The work pieces what you are going to get should be accurate. So thus the jigs and fixtures what you use also must be accurate. Otherwise your work pieces will not be accurate. So these are the different requirements of the jigs and fixtures. So the remaining part of it about locating principles and other things, we'll see in the next class.